Okay, good morning to one and all. So in the previous class, we have completed the practicals and as well as in the last before that one class of yesterday. So we have finished the transformation ratio and phase angle derivation of current transformation. So today we are going to discuss about the potential transformer. So the current transformer, it is going to bring the current back to lower value. Okay, like that, the potential transformer, it is going to bring the higher voltage to the lower voltage, it is going to transfer. So for the measurement of electrical parameter, these instrument transformers, they are going to bring the value from higher value to the lower value. So we'll check the definition of the power transformer here, no potential transformer. The potential transformer may be defined as an instrument transformer here, no. The potential transformer is an instrument transformer. It is used for the transformation of voltage from higher value to the lower value. So it is an instrument transformer, which one we are going to use for the reducing the voltage from higher value to the lower value here. For that reason, the potential transformer, that device we are going to call as potential transformer here. So higher value to the lower value, we are decreasing the voltage. Reducing means it is a step up transformer or step down transformer. Is it step up transformer or step down transformer? Yes,
step down.
Step down transformer it is. So this transformer is a step down the voltage to a safe limit value, which can be easily measured by the ordinary low voltage instruments like voltmeter, wattmeter, watt hour energy meters, and all the things over there. Okay. So this one, it is going to reduce into the safe value. It is going to reduce here now. So the potential transformer is made with high quality of core operating at low flux density. This one, I will check this diagram here. See here. It is a parallel transformer also we are going to call. As you can compare with the current transformer, this conductor itself, it was act as a primary winding. Yes, this one, other one, it one act as a secondary winding. Here, the primary winding line with respect to ground, we are using, this is the primary winding. This is the primary winding. Okay. And this one, we are considering as secondary winding here. Secondary winding. This one also, with respect to ground only, we are going to consider here. So the number of primary turns are very high here now. You can check, you can compare that one here now. See here, this is 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, here 9 numbers of turns are there. Here 1, 2, 3 numbers are there here. 1, 2, 3 numbers are there. So higher number of turns, which winding is have, that winding have the high voltage. All of you know the characteristics of the transformer. So this one, it is a lower number of turns are there. So lower voltage winding we are calling. The primary, it is connected to the line which is higher voltage, and the secondary, it is the higher value of the line, it is reducing into the safe value. It is reducing here now to a was as per the requirement or lesser value here now. So this is called potential transformer construction and working we are to call this. Okay, same thing they have written here. And to do the winding inside the core material, we are going to use that core material. What high quality core material we are going to use, they are mentioning here now, because having the low flux density, if the core is having low flux density, then the magnetizing current is very small over there. So the terminal of the transformer should be designed so that variation of voltage ratio with load is minimum, and phase shift between the input and output voltage is also minimum here. If variation with load voltage is minimum, then phase shifting is also minimum only for the input here now. See here they have mentioned here now, primary of potential transformer is having large number of turns. The number of turns in the primary winding is large, and primary is connected across a line, generally between one on line and earth here now. Hence, sometimes it is also called as parallel transformer. This one, it is connecting in parallel with the line here now. In parallel with the line here now. So for that reason, this one is, it is also called as the parallel transformer only also here. So many primary terms are there, but only few secondary terms are there for here. So that is going to step down or transforming the higher value to the lower value for the measurement of the voltage here. Now for the measurement purpose, it is going to reduce the value here. Now this is the just introduction of the potential transformer here. Potential transformer introduction here. The secondary of the potential is having very few turns here now and connected directly to a voltmeter here. Now we are going to measure what? Potential meter means we are going to measure the voltage we are reducing here now. For that reason, it has reduced to voltage value here now. Low voltage we are going to measure here now. How much voltage is we have reduced here now. So connected directly, as voltmeter is having very large resistance here. The resistance is very large. Across that one, we are measuring the voltage. Hence, the secondary of the potential transformer operates almost in open circuit condition. How it is operating as an open circuit condition here? Open circuit जैसे दिख रहा है क्या ये? Yes, anybody can you tell? Is this open circuit? Here voltmeter is connected. Yes or no?
Yes, sir.
How it is open circuit then? See, the open circuit is nothing but here we have given supply means it should be like this here. It should be like this. It should be open circuit. It is open circuit. So it is open circuit now. Yes or no? This one is open circuit, na? This
Yes,
part from here to here, it is open circuit. The open circuit resistance at this terminal will be high or low? In between these two terminals, what is the resistance? It is a maximum or minimum?
Minimum.
Minimum. Next, any other options? Maximum, minimum. Anyone? What is the formula for the resistance? What do you mean by resistance? What do you mean by resistance? Huh? Once again, come once again. Pardon? जोर से बोलो थोड़ा. समझ में नहीं आया मेरे को, आंसर ही सुना नहीं आ रहा. थोड़ा जोर से बोलने का कभी भी. See, the resistance which opposes the flow of electrons or current here now. Here, is there any current flowing from here to here? No. Why? Because it is open circuit. For the open circuit, the resistance is very high. That is called maximum. We are going to call it. It is not minimum. Where the resistance is high, and that condition, it is going to act as an open circuit. So here, this voltmeter is having very large resistance we are using, means the resistance here, what it will do, it will opposes the flow of electrons. So opposing flow of electrons is nothing but it will act as an open circuit only. Yes or no? समझ में कोई बोला था मिनिमम रहते बोल के, it is not minimum. The resistance of the open circuit is very high. For the short circuit, the resistance is zero here now. There is no resistance at all. Like that, we have to think here. Okay. So because of very high resistance, the voltmeter have very high resistance. So it is almost act as an open circuit only here now. Where we have stopped here now. Somewhere one terminal of it is earth to maintain. Why these people are joining now? Okay. As the voltmeter is having very large resistance, hence the secondary of PT operates almost in open circuit condition. It is having large resistance. For that reason, it is going to operate on open circuit condition. one terminal of the secondary of the potential transformer is earthed to maintain the secondary voltage with respect to earth. The output we are going to maintain with respect to earth. We are going to call that one, which assures the safety of operators over there. So the insulation cost, higher voltage का क्या चाहिए, higher insulation चाहिए. So insulation cost is reduced by dividing the primary winding into sections, which reduce the insulation between the layers here. Now we can reduce the winding, one winding, two winding, we can reduce that one also. They have mentioned here. So now we will go for the derivation of the transformation ratio of the potential transformer. Here up to here it is a working of transformers, potential transformer. If you have any doubts up to here, you can ask me now. Ask the doubts if you have. Otherwise, we will proceed for the next derivation. We will go. Any doubts? Hello, are you there? 30 students are there. Out of 30, nobody is replying. Okay, no. So we'll go for the next. The derivation will go. Before derivation, some parameters we are going to discuss, that what representation of the each parameters we are going to call here now. So main the flux we are taking for that to draw the phasor diagram. For that reason, phi is nothing but working flux here. Phi is nothing but working flux. IM is already yesterday class in the current transformer we told, that is magnetizing current, that is, and I is nothing but exciting or iron loss component or external circuit current here now. So I naught is no load exciting current here now. At no load condition, it is exciting current here now. So ES is the secondary winding induced EMF in the secondary winding, and VS is secondary winding terminal voltage. Voltage across the load is, that is called VS. At the immediate after the secondary winding, how much EMF induced, that is called ES we are going to call here now. So NP is the number of turns in the primary winding, NS is number of turns in the secondary winding, and current flowing through the secondary winding, that is called IS we are going to call IS. So RS is the resistance of secondary winding, XS is reactance of the secondary winding, RE is the resistance of a secondary load circuit, that is called external circuit. XE is the secondary reactance of secondary load current here. So the phase angle of secondary load circuit is nothing but tan inverse of XE divided by RE we are going to consider here. That is called delta we are going to call phase angle of secondary load circuit here. At the load side, secondary load side, that is called IS VS angle between that one here. Okay. So EP is the primary winding induced EMF here now. EMF induced in the self-induced EMF we are going to call induced EMF in the primary winding called EP here now. And IP is because of that one primary winding current flowing through the primary winding, total current flowing through the primary winding, that is called IP here now. The resistance of the primary winding, that is called RP. Resistance of reactance, that is called of the primary winding, XP we have considered here. This is the circuit we are going to use here. The equivalent circuit of potential transformer. Is there any change in the current transformer and this one? Is there any change here now? There is no change at all here now. There is no change at all. But previously we have discussed for the current values. Here we are going to concentrate on voltage value here. Voltage and current both here. Especially there is difference between this ES and VS here. ES is total induced EMF in the winding here now. VS is voltage drop across the load here now, this load here. Here we are using RE, XE, external loads we are going to use here. This is external excitation system, loss current, magnetizing current, and total exciting current, that is called I naught here. As per this, we can say, where it went. As per this, here, same formula I will tell that one. I naught equal to IM plus IE. Yes. I naught equal to IM plus IE. We can write like this. Yes or no? Two parallel current here up to here, the I naught will come from this. Some current will flow. This some current will flow again at this point. Both will sum here now. So summation is nothing but I naught equal to Im plus I naught here. Yes. So next, what is this current? This is the primary current here. Up to here, this IP is there here now. So here IP is there. At this point, it is called actually I naught minus IP. We can write like this. I naught minus IP. We can write like this. Otherwise, because of this current only, the IS secondary current will be producing here now. For the potential transformer, IS divided by number of turns we are going to consider here. IS divided by number of turns here now. Just a minute. Okay, so this is I naught minus IP we are going to consider. Otherwise, IP equal to total current equal to IP equal to, I will write here, IP equal to I naught plus the IS produced because of the number of turns, that is called, when we are taking the reverse order, that is called, that is IS by N we are going to call this. Here the IS is there, that one in the opposite direction we are going to extend, that is called IS by N we are going to call. So that is total IP we are going to get here. Total IP we are going to get here. So we'll start to draw the phasor diagram here now. First, I will take the magnetizing flux. I will take the reference here now. I will take this magnetizing flux as reference. So I will draw here, that is magnetizing flux, that is phi here now. Okay. So first we'll draw the I naught value. The I naught value, to draw that one here now, the magnetizing current and the excitation loss current we have to draw here. So the magnetizing current is in phase with the flux here now, and the current, that is only resistance is there. So that one it will leads by 90 degree here. IE leads 90 degree, or IM lags the current excitation current loss, that is by 90 degree here. So this is IE we are going to call here. So the total angle is 90 degree we are going to consider 90 degree here now. So the summation of these 2 points, that is going to give I naught value. So I will take the dot value here. So here also I will take the dot value, where both will intersect here now from 0 to that one, that is called I naught we are going to call here. So now can you tell me that one, this whatever the difference is there, the same difference we are going to get here also, from here to here? Yes, that is called IE. We can consider this one also, we can consider as IE only. Yes or no? So here IM, this is IE, this is I naught. It will looks like one triangle. This complete is one triangle or not?
Yes, sir.
So this part is over now. I will erase this one. Just a minute. Next, we have to draw the IP current we have to draw here. Total IP current here. Now, I told IP equal to I naught plus IS by N. So this one, the upper side we are going to consider as primary voltage, and this is secondary here. This part secondary we are going to consider here. Just further to draw the phasor diagram here. So the current here I will consider as IS, and this one EMF induced in the secondary winding always leads the voltage drop across the secondary load here. So it is leading here now. ES is leading by some angle here now. So that is called VS we are going to consider here now. Vs here now. So this one is ISRS, voltage drop across this resistance here now. That is called IS into RS. And from 90° to IS into XS here now. This is inductive load. This is resistive load here now. So there is 90° difference. Voltage drop across this one will be 90°. Yes or no? 90° lags that one. So 90° we have joined together here. So it will also form one triangle here now. This one triangle here now. That is called secondary voltage and all the things we have considered. Similarly, we have considered here IEP, induced EMF in the primary winding. Then the voltage drop across this one, that is called IPRP we have considered, and voltage drop across this inductive load, that is called IPXP we have considered. So our aim is we have to find the EP. We have to find here now. First, we have to find the EP. To draw the equation for the EP here now, already IS is there. To take the opposite direction, that is called IS by N. I will draw here now. The same magnitude. I will stop here now. So the IEP is the combination of I0 and IS. I have already told you now. So like this, by slat angle of with respect to the I0, you start to shift this one here now, the triangle dotted line, and this one also you can start here now, where it will join from the 0. That one it will give the total IP value it is going to give. Total IP value it is given. So this is the phasor diagram of the equation. So by drawing the equation, equivalent line, suppose this same angle we can draw one parallel line here now. Here we can draw. This is called IP. We can call that one. Then we can call this one as, again, with respect to this we can take here now. Like that, we can modifying the phasor diagram for the writing equation purpose here now. We have modified the equation here. Just check it now. Difference is there, so much difference. This part we are keeping as it is. With respect to this, we have changed a little bit here now. See here, we have taken for the current, it is IS by N. When we will take the reverse, current is IS by N. Suppose the same thing, if we have shifted the voltage here now. Suppose I have shifted the voltage, that is called Vs. I have shifted, means that is NVS. It will come here because this is NVS we are going to call for the potential transfer. Yesterday in the current transformer, for current we have considered NIS. Yes or no? NIS. And for the voltage, that is called Vs by N, we can have considered there. Understood?
Yes, sir.
So this one NVS, if we have reversed the voltage here now. So based on that, we are, why I am telling means we have taken here now. See here. Yes, where is Vs into N we have taken here now. Yes or no? This Vs we have taken. See here, we have not done what we changed. We have not any change. We have not done any change, means this is IS we have kept as it is here now. IS by N, it is not IS. IS by N we have kept as it is. This is IP we have kept as it is. Here, see here, this dotted line is there here. With respect to this one, we have taken here. Same line is there. Angle is same. It is like a parallel path only. This one and this one. Is there any difference here? No, same magnitude, same angle we are using, means this one is equal to this. We can call that. This line we have joined here. Okay. So this part is same only. There is no change in this part. And this VP part also there is no change. VP, EP and all the things. Only what we have changed, whatever the Vs is there, Vs into N we have considered here now. So instead of taking to the straight line, what they have done, we have made here one triangle here. See here. IS, RS, N we have considered here now. So IS, RS into N here. And this one, the secondary resistance here. Now for the inductance, it is 90° again we have considered here now. That is IS into XSN. Next from here, from primary will start IPRP. And next the primary, that is called IPXP here. So the voltage across, what we have to consider, we have to find out, that is called OA value we have to find out here. Total OA value we have to find out here. Here the angle is there, theta we have used here now, theta. This one is beta we have considered, that is angle between the magnetizing current we are going to consider. This delta is the phase angle between secondary voltage and secondary current here. Now here current is there, here voltage is there. That angle we have considered here. So that mirror copy we have reflected, this one we have considered delta, this one we have considered as dash is delta, and this one beta here. So now we'll start to write the equations here. Now see here, the turns ratio already you know that one, n equal to np by ns here, primary to the secondary. For the n equal to ep by es also for the voltages, that is called primary to the secondary. We are going to consider that one. I will not read this one here. Turns ratio, directly actual transformation ratio we have to do here. An enlarged cosine phasor diagram is shown here. Now this is the cosine phasor diagram is there. So theta is the phase angle of the transformer. Where is the theta? This is the phase angle of the transformer. That is angle between primary current here. Now this is the primary current. This one is the secondary current here. Now the here angle between this one is the primary to secondary here. Here VP is there. Here VS is there here. So that is VP and VS are reversed here. Now that is called angle between VP and VS. VS reversed here. Okay. The phase angle of secondary load circuit, that is called current between the angle between this one here, VS and IS reversed here. IS is also reversed, VS is also reversed here. Beta is the phase angle between IP and VS here. Where is the IP here now? That is beta here is there. This is the IP here. Continuous straight it is. This is IP line we have taken here now. This one IP, and VS reversed is this one here now. So angle between this one is beta we have considered. So what we have to do? We have to identify this one I will consider as A. This one I will consider as B. This one I will consider as C. This one is D, and this one is E here now. E we have considered. We have to find the total voltage, the ratio between OA we have to identify. So for the OA, I will tell the flow how we are going here now. First we will go like this, then 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 we will go like this. So OA equal to up to VP we can calculate here. Previously in the primary current we have calculated, here voltage we have to calculate here. Transformer, potential transformer is there. Yes or no? Potential transformer means we have to calculate, that is R equal to VP by VS is there. So that is we have to calculate VP here now. So up to VP, what is the equation we have to identify here? Okay, so we'll start that one. Now OA equal to VP cos theta here. How it came VP cos theta? See here, this one we'll consider one triangle here. Now I will draw here. You can check that one. It is like this. Okay. Sorry, what happened? Okay. It is 90 degree. Just imagine this is 90 degree. This is OA. So this is VP is there. Okay. VP is there. This one is adjacent is there. Adjacent is nothing but VP cos theta. Yes or no? This angle is theta is there. Yes. VP cos theta we can write adjacent here now, and this is opposite, that is called VP sin theta. We can write like this or not? Anyone reply? You can rotate this one also. It is like this. This here, it is like this only. आवाज आ रहा है? कोई तो रिप्लेस हो. This is VP. We can write this one as VP cos theta. This one as VP sin theta. Yes, we can write like this.
Yes, sir.
So the VP cos theta we have written here now in this place. This is OA is VP cos theta. Okay, I will erase everything. Again, you should not confuse. Just for your understanding, I have drawn here now. Next, from the phasor diagram, how we have to draw the OA here? OA equal to what we have to consider. First, we'll start from here. O से चालू करेंगे. इधर से कहाँ जा रहे हैं? This is here now. N into VS here now. N into VS we have written here. Next, this one is there here now. Okay, N into IS RS. What is the angle here now? This one, delta is there. So that is adjacent line is there. that is n into ISRS cos delta we are going to consider here now. Next, this one n into IS XS, this one opposite side is there, that is called sin delta we have used here now. Next, this part will start here now, either say ऐसा गए. Next it will start here now, IPRP here now, IPRP. But what is the angle here now? We have drawn this angle as beta here, we have taken here IPRP, that is called, it will act as adjacent line here now. So this is opposite, this is adjacent, this is hypertenuous we are going to call. So IPRP cos beta, IPRP cos beta. Next we will call this one as IPXP sin beta. So this one OA we have drawn from the phasor diagram up to this VP cos theta here. VP cos theta equal to n into n VS, n IS RS cos delta, n IS XS sin delta, IPRP cos beta, IPXP sin beta here. Okay, so we have drawn here now. Now substitute OA, already we have derived the equation, that is called, in the place of OA I will substitute VP cos theta here. I will substitute VP cos theta. The other things I will keep as it is here. As it is, I will keep that. Now what I will do here, from this circuit, NVS I will keep as it is here now. From this part, I will take outside NIS, I will take outside here now. I will take NIS outside here now. I will take the open bracket. The inside left is RS cos delta. RS cos delta I will write. Plus here also I have taken NIS, I have taken outside. So XS sin delta is left here now. XS sin delta. And these all the things IPRP cos beta, IPRP sin beta, I will write as it is. So up to here, this one we are going to call as equation number 1. Up to here, if you have any doubts, you can ask me. Yes? If you have any doubts, you can ask. Hello? Hello? आवाज येते का? Any doubts? I am asking to you people only.
No, sir.
Okay. Just a minute. So next we will go for the modified equation. By modifying that one, what we are going to do here, the phase angle theta, this one, this angle, the theta is very small as compared, both VP and VS are reverse, can be taken perpendicular to the theta here. So we are going to consider this theta is very small. For that reason, what we can consider here now, approximately we can consider that is OCD. Where is the angle OCD here in the diagram? This is O, this is C, and this is D here now. This is O to C gaye, C to DI. What is the angle we are using here now? That is called beta we are going to use here now. This is the beta here. This complete beta we are going to use here now. OCD angle is approximately beta. And ECD, the angle ECD is nothing but here E is there, here C is there, here D is there. That is called delta we are going to use here now. ECD, we can consider this one here now. This one equal to this one here now. Same here now. So E, C and D here now. That is called delta we have assumed here now. We are assuming delta here. I will not give rule number 2 attendance. Next. So IP cos beta equal to, see here, IP cos beta equal to IE plus IS by N cos delta here. Where is the IP here now? IP here now. This one. So according to this one only, OCD, IP cos beta equal to, see here, OCE, we have consider OCD by considering that one. I will erase everything. Just a minute. Where it went? I'll erase here now. So considering this one here now, this triangle, I will consider this one. Okay, here IP is there. Okay, this one is IP we are going to call. Here, this one is IE only, na? Here IE is there. Up to here it is IE. This one also we can consider as IE only. Yes or no? This is also we are considering as IE only. So for that reason, what we are writing here, IP cos beta equal to IE plus IS by N sin delta here now. This IE plus this IS by N here, IS by N we are considering here now. This one plus this one here, IS by N sin, the angle of this one is delta. So that one we have written here. IP cos beta equal to IE plus IS by N cos delta. Similarly, IP sin beta equal to this one we are going to consider IM. IM we are using IM plus IS by N sin delta here. This is plus here. Actually, it is not minus, it is plus here now. IM plus IS by N sin delta. So this one we have to substitute in equation number 1 here. Previously whatever we have, and now the theta is very small, means the cos theta equal to we are going to consider as 1 only. So cos theta equal to 1 is nothing but VP cos theta equal to VP we are going to consider. So this one by substituting in the equation number 1, VP cos theta equal to VP ho gaye. NVS we have kept as it is here now. NVS we have kept as it is. NIS previously kya tha question? NIS we have substituted, that is RS cos delta we have substituted here. NIS RS cos delta XS sin delta, this one up to here we are keeping as it is only. Only thing is IP also we are keeping as it is, where RP cos delta and XP sin delta here. IP cos beta plus IP sin beta is there. On that place we are going to change here. IP cos beta ka place mein we are going to substitute this one, and IP sin beta ka place mein we are going to substitute that equation here. So up to here there is no change at all here now. There is no change. In this place IP RP cos beta is there, was there. So RP I have kept as it is, and this IP cos beta ka place mein I have substituted this one. IE plus IS by N cos delta मैंने इधर सबमिट किया. ओके, प्लस इधर इक्वेशन था क्या था, IP XP sin बीटा था. IP XP का प्लेस में I have substituted this term here. IM plus IS by N cos delta into XP I have kept as it is. I have kept as it is here. So is there any doubt here up to here? बोल दो, डरो मत. Any doubts? Hello. These all the equations we have substituted in equation number 1. Equation number 1 में substitute करने के बाद हमको इधर तक आ गए. Next क्या करना है? Next I will tell you. See here, up to here, here also cos delta is there. Here also cos delta is there. Here also cos. This is actually sin delta. They have done a mistake here. This is not cos. This is sin delta here. So this is cos delta. Here cos delta. Here sin delta. Here sin delta is there. What I will do, I will write NVS as it is. I will write here now. So IS cos delta, here IS as already we have taken outside. The cos delta also I will take outside here now. So N is sent inside here now. NRS the term left. NRS I have written here now. And from here, that is, so we can consider as this one IS by N is there. Yes or no? IS by N here now. So that is, what is this one? RP. This RP we have to send into inside here no. RP by N we are going to consider. IS already we have taken outside here. So IS cos delta we are taking outside. So the term is left 1 by n into this one is nothing but RP by n. This one term. This complete equation, this one and this one, we have made this equation here. Next what we will do, I will erase all the things. Here xs sine delta is there, and here this one is sine delta. I have told sine delta it is nothing but, so xp into multiplying that one, sine delta is there already, nis outside is there. What I will consider, I will take outside ns, is and sine delta here. Now from this one sine delta outside liya to n and xs will term is left here. Now n into xs we have written here, n into xs, and from this term sine delta we have taken outside, and that is called xp. We are going to multiply xp by n it is now. Okay, xp by n it is left here. So ip rp and im xp we are going to keep as it is here. This ip, this is ie rp, and here im into xp, that is we have left here. Now this one equation number 2 we are going to consider. This one as equation number 2 here. We consider as equation number 2. Next what we are going to do, this complete term is there here now. That is we are going to consider here. What we will do here now, this n is there, I will take outside here. I will take outside here. Is by n I will do this one here. Is by n, here also a n है, इधर outside लेता हूँ, ये भी is by n हो जाएगा. So 1 by n we have taking outside means here you have to multiply into n. This one we have to multiply into n here. You have to multiply into n. It will become n square rs, n square 1 is by n cos delta n square rs into rp plus is by n sin delta n square xs plus xp. This term will be comes over. Other remaining parts are same as it is. Remaining parts will be same as it is. So this n square rs plus rp I will go to consider as total resistance of the primary winding, that is called rp. We are going to consider here. Rp I will consider here. Now I will write the equation here somewhere. Rp equal to n square rs plus that is called rp here. Rp. Similarly, this n square xs plus xp, that one I am going to consider as primary reactance, that is called xp here. Udul, हर ब्लॉक चेक करो एक बार. Okay, so xp equal to n square xs plus small xp, that is called small xp we are going to call here. So this term we have replaced here now, xp and rp. So other things we have kept this one as it is, this one as it is here. So is cos delta as it is, is sin delta also as it is, we have kept here. So next what we will do, we'll go for the equation, that is simple direct equation we can write here now. From this one, from here also is by n is there, here also is by n is there, so both common. I will take that one. Okay, so I will take n vs as it is, is by n will take common. So rp cos delta plus xp sin delta plus ie rp im xp we have written here. Now this one you consider as equation number 3. This is the actually final equation of the VP here. Final equation of VP. But only one equation we are not going to get. We are going to get 2 equations actually for the VP. So what we will do now? So RP equal to equivalent resistance of the transformer referred to the primary side. XP is equivalent reactance we have considered here. This RP and XP I have written here. Actual transformation ratio voltage is R equal to primary voltage divided by secondary voltage. We know the formula here. So VP we have derived here now. So VP you substitute here now. N Vs divided by Vs, that is called N only. N we have written here, and Is by N into this RP cos delta XP sin delta plus IS IERP plus IM XP divided by VS. We are going to write this one. This is the transformation ratio we are going to call it. This is the transformation ratio here. Now this one we can consider as equation number 4 here. Now equation number 4 we will consider. Next, what we will do that one, equation number 9.27 may be written here. Now what we have considered, instead of this one NIS cos delta and all the things previously we were written, that equation we will write as it is. Other method is also there. Directly this one RS by हमने RPXP use किया ना, RPXP. Instead of that RPXP we can use as equivalent secondary resistance and secondary reactance also we can use here. Whatever RS plus RP by M square is there, that term we can write as RS, and here XS we can write here. In the place of RPXP, capital RPXP, we can write RS and XS also, secondary reactance, equivalent resistance here. By doing this one also, we have to do the derivation here. Now same derivation will come here. Now again, it will only in the place of RPXP changes हो जाएगा. इधर RP है, sorry, इधर RS and इधर XS आ जाएगा. Other things are same, and here IS by N is there. Here N into IS it will come over there. Here secondary consider किया तो N into IS. Primary equivalent we have considered means that is called IS by N. It is going to come here. Other things are same here. And in the place of RP we have used here RS. XP we have used XS here now, and same thing we have considered. Using this equation 9.28 means this one, equation number 3, and 9.30 this equation. The difference between actual transformation ratio and turns ratio is here we have considered this N I will send into what? LHS side. So R minus N it will consider here now. So IS by N, this equation we are writing. Just a minute. Okay. This equation, sorry, this one. N I will send here, the R is there. I will send N into this side, it will become minus R minus N. So IS by N we have kept as it is. RP cos delta plus XP sin delta as it is, plus IERP IMXP IERP IMXP divided by VS here. This is one equation, final transformation equation. Next, for this one here now, so R equal to N is there. This N you send into this side, it will become R minus N. That is called NIS RS cos delta plus XS sin delta plus IERP plus IMXP divided by VS here. Now, these two are the transformation equations of the potential transformer here. These two are the transformation equation of the potential transformers. Okay, so two methods. One is equivalent resistances, secondary or primary, both we can consider here. So next one is the phase angle equation we are going to consider, that is called tan theta equal to AB by OA here. No, so AB formula we have to consider here. No, A to B already we have derived, that is IP XP cos beta minus IP RP sin beta plus NIS XS cos delta minus NISRS sin delta here. No, OA only we have derived just now. इतना बड़ा equation लिखा था ना, same equation we have to write here. No, so deriving this one here now, IPXP cos beta you keep as it is minus IPRP sin theta. We can consider this whole thing here now, but the terms in the denominator, this term is there here. IPRS, IP and IS are very small here now because it acts as an open circuit here now. Wherever IS is there, wherever IP is there in the denominator, that term we have to neglect. Here IP is there, this one you neglect here now. Here IP is there, you neglect here now. Here IS is there, you neglect here now. And here IS is there, you neglect here now. So only term left is NVS term left, only NVS we are going to consider here now. From this one now, you take XP outside, you take the XP outside here now. So XP equal to IE plus IS here, this one. X either XP we have taken means IE plus IS by N cos delta minus either RP we are going to take outside, IM plus IN sin delta. So NIA XA cos delta minus NIS RS sin delta we keep as it is. By deriving some simplification by doing this equation here now, again the theta equal to tan inverse R also we can consider, or directly we can write here now IS by VS X cos delta minus R sin delta IEXP minus IM RP divided by NVS here. Now, this term simplifying here we are going to get here. This is the phase angle equation we are going to call it. Supply chain focus. Okay. So the phase angle equation, same thing whatever we have discussed for the CT, that is nominal ratios are there, some voltage ratio here we can consider that one. So that is called the nominal ratio minus transformation ratio here. Now already R ka formula we have derived, or directly we can calculate R, then you can substitute here. Now the phase angle error also same formula we are going to use, whatever the phase angle equation is there, that is phase angle error equation here. So it completes the potential transformer. The next class will discuss about difference between CT and PT here. There is no much difference is, that is the current transformer, this is the voltage transformer. The working operation, it will act as an open circuit, that will act as a closed circuit. It is a parallel, that is a series. Like that, some differences are there. We are going to discuss in the next class. Okay. So we'll stop here only and we'll continue in the next class. समझ में आ रहा है क्या? So exam timetable is already displayed. Practice the MCQ questions. Okay. So next, if it is delay for the exam, means you will get the offline exam. Remember that one. For that reason only they are hurry to conduct online examination. The government is announced that nowadays, now onwards, we have to conduct offline examination. Okay, we'll stop here only and we'll continue in the next class.